Unit 3, Time Value of Money, Lecture 6, Annuities, Part C. So in this last lecture on annuities, we're going to look at two types of annuities which are slightly out of the ordinary. We're going to look firstly at deferred annuities, and a deferred annuity is the same as any other annuity except that its payments don't begin now. In other words, it begins at some later period. So the example we have below is a 5-year or 5-period deferred annuity. So you get 5 annuity payments, but it only starts at the end of year 3. So we can find the present value of a deferred annuity in the same way as any other annuity, but we have to be mindful that there is one more step required to get it back to time 0. But before we do that, we have to understand that when we're calculating the present value of an annuity or the present value, it is always one period before the first payment occurs. So if the first payment occurs at time 2 and we find the present value, that present value is actually for time period 1. So in finding the present value of a deferred annuity, we will first use the present value equation, and then the result of that we will discount back to period 0. So if we're using a 10% discount rate, we find the present value of the deferred annuity, which at time 2 is 379 Rand and 8 cents, and then we've got to discount that for the further 2 periods to bring it back to time 0, which is 313 Rand and 29 cents. And if we look at the next slide, it shows us that in more detail. Using the financial calculator, we would also do this in 2 steps. In step 1, we would discount the 5-year annuity with n equal to 5, I over y equal to 10, PMT is 100 to get a present value of 379 Rand and 8 cents. But this value would be applicable at the end of year 2. The second step would be to discount that value back to year 0. And here we would set n equal to 2, I over y equal to 10. And our future value would now be 379.08, giving us a present value of 313.29. Now we're going to look at calculating the value of an annuity with uneven cash flows. So sometimes you get an investment which offers you a regular stream of cash flows, but they're not of equal value. And we can use this using both the financial calculator and the formula using the principle of value additivity. So if we look at this example, we assume that an investment offers the following cash flows. If you required a return of 7%, what is the maximum price that you would pay for this investment? And if we look at this investment, we're getting 100 Rand at the end of the first year, 200 at the end of the second, and 300 at the end of the third year. And using our normal formula with value additivity, we end up with a value of 513 Rand and 4 cents. Now, instead of using the formula, you could actually use your financial calculator to do this calculation. You just have to use the cash flow function. So if you look at the third row from the top, the middle button, you'd see CFJ. You would have to input your cash flows into that. So we have no cash flow 0, so you put 0 for cash flow 0. You put 100 for cash flow 1, 200 for cash flow 2, and 300 for cash flow 3. For your interest rate, you input 10 for I over y. And if you looked at the second row from the top and second button from the left, you'd have to press the orange arrow to find your NPV. And you should end up with 513 Rand and 4 cents. So we're going to end this lecture looking at an example of how to calculate the future value of uneven cash flows. So suppose you were to deposit the following amounts in an account, paying 5% per year. what would the balance of the account be at the end of the third year? So your three cash flows at the end of years 1, 2, and 3 are 300, 500, and 700. And it'll probably be easiest to use the formula here. And using the formula, we end up with a future value of 1,555 Rand and 75 cents.